What I'm going to be doing today is a little bit different than the talk. Normally, the way I do this talk is I will type some code out on screen and explain what it does, and then wait for everyone, like walk around the room and wait for everyone to catch up typing and make sure everyone's code runs before I move on. In this case, we're all virtual, so I think what I'm going to do is I'm going to be trying to explain the concepts and sort of give you an understanding of the code that I write, and not expecting you to transcribe it as I'm typing or get it running while I'm running it. So just kind of hold on to the ride, try to take in what I'm saying, and then I'll stop to ask questions and that sort of thing as we go. So before we begin, we need to first go over just sort of a fundamental concept that is important to the internet. That is the way you want to think about website programming. So a web, I guess we're just going to hop right in. A website is kind of it. I always change how I do this explanation. When you visit a URL in your web browser, what happens is the browser submits what's called a request to the server that backs the URL you typed in, and then the server returns with a response. It's request, response, request, response. And for a normal website, that response, more often than not, looks like HTML. So a request is just, there are different types. Turn on closed captions. Is there a closed caption setting somewhere? I assume that's what you mean by CC. It occurs to me now you might not hear what I'm saying. Does anyone have any insight on how to turn on the captioning system? I'm not seeing any buttons. Sorry, I don't know how to turn that on. If one of my moderators wants to tackle that, that'd be great. Anyway, so a website is entirely made up of request response, a series of requests and response. All of your interaction on a website, any website at all, is your browser making a request and the website sending back a response. The most common type by far, there's different types of requests that do different things, but the most important thing to know for the moment is that when you type in a URL and hit enter, the browser makes what's called a GET request. So our website, the very fundamental kernel of thing we need to call ourselves a website is we need to respond to GET requests with some data. And if we're wanting to make a website that people use, we want to respond with HTML code, although you can really respond with whatever you'd like, and we'll get to that in a moment. So with that explanation out of the way, it was a little bit long-winded, but basically request, response, our entire programming model today is going to be handling, reacting to and handling requests. So how do we do that? Well, we're going to be using a library called Express and a tool called Node. So the first thing I'm going to do is I'm going to make a new project. Hey, look, I still have the folder from last year. I'm going to go ahead. I asked you all to install Node before we got started. We're not going to live. Can I zoom my screen? Yeah, absolutely. Oh, that reset the zoom. Sorry. We're not going to like live code together, but all the commands I'm showing you will be Node related. npm init is how you set up a new project in the Node ecosystem. I'm not going to go over Node modules and stuff too much, but Ali DiNapoli does in her React talk a little bit more. So go watch that later today if you're more interested. So whenever we're doing a Node project, we always the like core of the project is called the package JSON, which the command npm init generates for you. And it's simply a description of the name of the package, some metadata about it. Doesn't really matter. More important thing is that it exists. That's really all we care about for now, because it includes our dependencies. So what's a dependency and why do I care? Well, like I mentioned, we want to handle requests and respond to them. And Node can do that natively, of course, but Node's standard library is a little verbose. So it being a hackathon, we're going to jump right into using a library to do the heavy work for us. So we're going to use a library. And I'm showing you some to make it a point that it's well documented, just to really drive home that go look up the documentation when we're done. Anyway, so we're going to run the command it gives us because it gave it to us. And so that package JSON file we generated before now has a dependencies area and Express is listed. So that's how you deal with packages in Node. So let's actually use it. Back to the Express documentation, just to really drive home this point, I'm actually going to start with their hello world. So yeah, let's do that. I'm going to open my code editor in the folder I created. And let's make a new file. We'll call it index.js. And we'll just start going. And import statements, and there's a couple different ways of doing importing in JavaScript just because of historical reasons. But for now, we're going to be using the require call. We're just going to do a little bit of setup. And then I'll talk through what I'm doing when I'm done typing. We'll type these out. Bear with me for just another moment. I don't really want you to try to type as I'm typing. I find that slows us down a lot because people spend a lot of time trying to transcribe the exact syntax. If you're not already familiar with the language, you know. Okay, so what the heck did I just do? If you've never seen JavaScript before, let's just go through a little bit of syntax. Const is how you define, there's actually 3 different ways to define a variable because of course there are, but const is one of them. So when you import things using the require statement, you just assign them to a variable and then use them at will. Express specifically, this is just like how you set up Express. We've defined an integer variable called port, and we'll get to that in a moment. And then we have this app.listen call, but we'll get to that. Let's look at this. So this is a little bit, maybe it's intuitive, or maybe it's very foreign looking, or maybe it's both. There's a lot of symbols going on here, so I'm actually going to break this out. Function get hello message. So what I'm going to do is make this a little more clear. All right, so app is our Express instance, and it's going to handle doing all of the web server-y stuff that I was just talking about. So it's going to listen for requests, and then it's going to call our functions when it receives a request. So app.get takes 2 arguments and simply is saying listen for get requests. And the first argument is the path of the request. So as you know, when you go to a web page, you can go to google.com, or you can go to google.com/maps, or you can go to google.com/mail. Actually, I think that's mail.google. Anyway, point is, URLs have paths on them, and that just gets that's part of the request. Every request has a path on it, just like a web page. So we're just going to say at the /path, which is just shorthand for like the main page. If you don't specify a path, then it defaults to /. On the main page, when you get it, we're telling Express, when you get a request to the main page, please call the function that I've specified here, get hello message. So something that might be really unusual if you're coming from a Java programming background or perhaps a C programming background, or if you're pretty new to programming, is that in JavaScript, you can pass functions around like they're variables. In fact, functions can actually be variables. So in this case, we're using the getHelloMessage function as the second argument to our app.get call. This is one function call with two arguments. First one, second one. I did this for clarity, but you don't need to write these out. Oh, is my audio bad? What's bad about the audio? Let me check my audio settings. Staticky. Is it any better now that I've just turned the volume down? No. Let me try a different input. Is this any better? Yes? All right, I'll just use my camera audio then. Oh, I have to do this again. One sec. All right. Did you guys hear me well enough to catch what I was saying? Okay. Anyway, what I was saying is that in JavaScript, functions are first class. You can make them inline. You can assign them to variables. You can pass them around like they're variables. Please zoom in a little more, of course. Sure. So that's what we're doing here. App.get is simply registering a callback. So when you pass in a function with the intent of, hey, please come call this function when something happens in the future, we call that a callback. That's a really common pattern in JavaScript. So we'd say get hello message is the callback for the slash request. And so what's down here is actually the same exact pattern, just a little bit different. App.listen is an instruction to the Express app to start the web server and listen for requests. And the first argument is port, what port to listen on. We'll get back to that in a second. And then the second argument is the function. Now this looks super different than this because there are actually three different ways to define a function in JavaScript. The first, this is called a named function. It's function and then the name of the function. The second is called an anonymous function because it's not named. It's assigned, it's used as an expression. And then the third is a special type of anonymous function called an arrow function. So the point of this is that there are three different ways to define a function. Whenever you see the word function, it's usually pretty easy to just intuitively see what is happening. But if you see this arrow syntax, just know that that's defining a function. So what we've done here is it's much like this app.get, but instead of making a function and then passing it in later, we're just going to make the function inline. In fact, we're going to use this terse little arrow syntax. So this simply defines a function and immediately passes it in to app.listen. So in the other syntax note, just so that you can see it, is with an arrow function, if you put an expression without curly braces, if you just put like something that evaluates to a value on the right of the arrow, it'll just implicitly return. So this is the same as. Yeah. So that's all I have to say about that. We'll come back to the syntax a little bit more as we need it. Okay. So the important takeaway was passing functions around. Now, for some reason, I can't save this file. There we go. Let's take a look at running the code. So all we got to do is just node index.js. And now we've printed a message. So I mentioned before, this is instructions to tell the Express app to listen for requests. The callback is a function it will call when it starts listening, and our callback simply says to console.log. Console.log is the same as system out print line or print in Python. So it started listening and logged our message, which is cool. That's what we wanted. So now let's take a look at our website. I don't know if you can see that, but that says hello world. Awesome. We made a website, class dismissed. Just kidding. But now we need to actually do things with the website. So obviously we don't want to just say hello world. We want to say it bold as a decent starting point. Let's make it look like something. Web pages on the internet are described with a language called HTML. So if we look at, for example, the Sunhacks page, in whatever browser you're in, F12 or Shift-Command-I or Shift-Control-I, Control-Alt-I. Anyway, if you right-click in your browser and you're not in Safari and you click Inspect Element on a website, you'll get to this. It might look a little different if you're in Chrome. It's called the Developer Tool. I'm not going to show you quite how to use it yet, but the important thing I wanted to demo was what HTML code looks like. So we can make that tiny and make this big. HTML simply is these like tags that are surrounded by angled brackets that have stuff in them. And there's a bunch of different tags to know, and this was probably a poor choice as an example website just because it's actually it's pretty simple. Okay, this is a good example. All right. So one of the tags that exists in HTML is the H1 through, I think, H2, H3, H4. I think there might be H6. I don't think it goes any higher than that. Point is, these are meant to be like heading text, so they're bigger by default. We'll ignore the class thing for now. But the thing to show off is that if you wanted to make text in H1, you simply have the tag, you have the content of the tag, and you close the tag. And then, as you may or may not have guessed, yeah, it doesn't make anything weird. It's just the best example would have been if I had written like a bare bones website initially, if I could be bothered to ever do preparation work. Anyway, tags, takeaway here. HTML is made of tags. The web is made of HTML. Tags are angle braces with like a name and then some information about the tag, and then the content, and then a closing tag, usually. And tags can be nested inside of other tags. So right now we've got div, 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 h1. They're nested. We'll go into this in a little more detail later, but you are going to have to do some independent research. But the important thing to know is that we need our web page to send HTML. We need, our web server to send HTML to the client. So to demonstrate that this works, let's just write some. We're sending back just a plain string. We're just going to write a little bit of HTML, just a little bit of HTML. We've inserted h1, which is the tag that makes text big and bold by default. You can always override the styles the tags do, but I digress. Every time we make a change to the code, we need to stop it with Control-C and start it again. So now when I refresh, it's bigger and it's bold, which is exactly what we expected. But as you saw from the Sunhacks website, view page source, the amount of, like the way that the code looks, this is not something that you're just going to type into a string in your JavaScript code, right? You're not just gonna like make one gigantic string and escape all of the new lines and stuff like that. I think my screen preview is broken. Anyway, this type of thing, I'm not just going to sit here and type this out right here. You want something that can help you manage that. And more to the point, basically every web application you'll ever interact with is like a handful of templates. So if you think of the fundamental purpose of a web application is to like take some data from the user and then like do something with it and then spit it out in some way. Generally, the way these things work is you've got like an HTML template and then you can fill data into it on the fly. So we are going to need a templating library to help us do that. And just to show what I'm talking about, let's do something like, let's make our little test website just tell you what time it is when the web page loads. That seems like a reasonable thing. The way to get the current time in JavaScript is make a new date. Hello. So we'll do something like this. Hello world. It is. We're going to do some fancy string concatenation. D dot to locale time string is the name of the function. Don't worry too much about this. Just in JavaScript, the date object represents a certain moment of time, and to locale time string reads the context locale and turns it into a time. Anyway, the important thing to know is that now when we restart our code and we reload the page, it tells us what time it is. Of course, it doesn't actually update. And if you're paying attention at home, the reason it doesn't update until I hit refresh, which is what I'm doing right now, is that the page only loads once. The flow is I type localhost 3000 into my browser. I hit enter or refresh. It sends a request to my server, and then the server sends a response right back. And that is it. There is no further interaction between the two parties. Thus, the website is how it looked when it loaded. Of course, there are interactive websites out there, and we will get to that. But for now, it's enough to say simply inserting values into strings like this gets clunky very quickly. So we're going to install a library to help us out with that. We're going to install handlebars. So this is, this is the one I usually use. There's a plethora of templating libraries on the internet available for Express at your disposal. But for now, this is one I'm familiar with, so it's the one I'm going to show you. It's called Express Handlebars. In fact, NPM's website even gives you a little button you can click to copy paste the thing you need. So we're going to install it. And we're going to follow its instructions on setup. Copy pasting. You know, something you realize really early on working as a professional software engineer, it's not normally this simple, but a lot of your job ends up being reading documentation and applying it in some way. Okay, so the way that Express Handlebars works is we write ourselves HTML files and leave ourselves little placeholders. And it expects the sort of placeholder HTML are called handlebars templates. Makes sense? And it expects those to be in a certain directory structure. So I'm just going to make that real quick. We're going to make a views folder at the top level. And we're going to make a layouts folder, and I'll go over both of those in a moment. Home handlebars, and then we'll make a new file layout called main.handlebars. So the idea behind a layout is like you'll have a template for certain types of data, a view, in other words, and then a lot of like the ancillary parts of the website, like the navigation bar at the top, or maybe like the sidebar, stuff that's the same on every page, you can extract into a layout. And that's not like a fundamental web thing. That's just how this library happens to handle that. So we're going to do that. Just a quick primer on HTML files is that normally you start with the HTML tag, and then you have a head tag. And the head is where metadata about the page goes. And then you have a body tag. So your HTML file usually looks something like this. So what we're going to be doing is the layout is going to have like all this. and then the main is just going to have the inner content of the body. And then just to demonstrate, I'm going to open this file. If you name a text file .html, you can just double click it to open it in your browser. You can see I said before, this is the page title in the head, and then this is the content in the body, and this is the page title, it's in the head. I know it's a little hard to see, but that's what it says, and then this is the content. So let's translate this into a template. We'll probably want to build ourselves a mechanism to be able to set the title of the page based on what we're doing, but for now we're just going to set it. And let's go ahead and make ourselves a body section. And then the way you place, we're going to leave ourselves a placeholder for the home, for the various templates to fill in. And the way you do that in handlebars is just like that. And again, all the stuff I'm doing right now is documented directly in their README. It's all right here. So don't worry too much about following along or paying close attention to exactly what I'm typing. Just kind of get the broad strokes, you know? So our main handlebar is going to take care of the layout of the page itself, and then our home handlebars is what we call a view. It's like a specific page, a bit of content. We're going to do this just the content. We'll leave ourselves a placeholder and call that placeholder current time. So now we need to render it. Before, when we wanted to send a response, we had, I'm going to delete this, it's already annoying. When we wanted to send a response, we would take the response object and say response.send. But now that we have a templating library, it actually becomes response.render. And the first one is the name of the view, which is home.handlebars, so just home. And then the second argument, that thing, is an object containing a key value pair of the names of these placeholders and their values. So let me type it out and then I'll just talk through what I've just done. It's already been half an hour. Wow. Current time is what I need to call it. Current time. And d.toLocale time string was the function we use. So what the heck is this? In JavaScript, objects are simply a pairing of the name of something and its value. So an object might be, let's say we wanted to make me an object. We might say name Chuck. We might say age 24. And we might say pronouns he, him. So an object is simply a list of things. It's kind of like a dictionary in some other languages. It's really, really free form and loosey-goosey. And it's basic. It's the notation is the curlies and then colons and then commas between all but the last one. And that's it. So this function call, response.render, the first argument is the name of the view, and the second argument is an object where what data to fill out in these placeholders we left ourselves. So let's see if this works. Please feel free to stop me in chat if I'm not making sense or if I'm at all incoherent. Here we go. Hey, it works. It looks exactly the same. I probably shouldn't have made it exactly the same. I'm going to make this hello world 2, just to, be absolutely certain that it works. Hello world 2. Hey, look at that. So now I don't have to worry about concatenating strings or adding strings together or anything like that. I can just write a template and render it. All right. So we're making really good progress. The other thing I need to show you is how to handle different pages. So the first most obvious thing is if you just have another page, you can just put it in the path. And then I'm going to use the shorthand notation here that I talked about earlier. Also, the shorthand I'm using is going to be what you'll see in the Express documentation and in most tutorials is this. Okay, render. We'll make a new template called 2. All right, so make a new file, 2.handlebars. This is page 2. All right, so now if we start our application again, we still have this, but if we go to /2, it's probably hard to see on your screen, but I have typed in 2. You get this as page 2. Oh, shoot. I just realized I have relative line numbers turned on, so they change as I move my cursor. 1 second. Line number. I'm so sorry. I forget that I do that. Himanshu, could you, which lines do you need some elaboration on? 7 and 8. Ah, perfect. This is just setup code for the library that we're using to render. These handlebars files are rendered by the Express handlebars library. This is simply setup code that they provide on their README. So it's going to be a little bit different depending on what library you use, but it's truly right here. There's nothing to understand. It's just the Express APIs for setting your view engine are doing this. Yeah. Yeah, so render, when we send a response, normally we just send a string or send some data, but Express's render function hooks into these view engine stuff that we set up before, where it'll send a response, but the content of the response will be what comes out of the template. They call that rendering the template. So it's going to combine the view that we specify here and the data that we specify here and synthesize some HTML, render it, and then send it as the response. It's a convenience method. So yeah, response.render is built into Express, and I can demonstrate that. Right. API reference 4. Go over to the response, res.render. Renders a view and sends the rendered HTML string to the client. Optional parameters. Yep. Hopefully that makes sense. Basically, you to hook up a web page, you listen for its request, you make a view for it, and then you render that view as the response. So now we've got 2 web pages. We've got our here it is. We've got page 2, and we've got normal page. I wish I could zoom in on the browser itself, but that's okay. Cool. Glad I helped. Oh, also another thing you may or may not have noticed, depending on how closely you're watching me, semicolons are actually optional in JavaScript. I'm in the habit of doing them because we use them at work, but I forget them sometimes, so apologies on that. Don't let that trip you up, although it's kind of awful. The other thing to know is a lot of times URL routing is not static. So if you have something like Twitter, Twitter works by the name of the person's profile you're looking at is in the URL. And of course, the Twitter programmers didn't go through and make an entry for every single Twitter user or something. There are programmatic ways to access the contents of the URL and to match that. So the way we do that is with what's called a URL parameter. So it's going to be something like this. We'll say /profile/name. And so what we're going to do is we're going to make a profile view, and we're just going to say hello to the person. So we're going to res.render. We're going to call this view profile. And we'll pass a name, rec.params.name. I wish I knew how to dismiss that huge VS Code pop-up. Okay. So what we're going to do is we're going to make a view called profile, and we're going to render it by passing in a name. And the way we get to that name is request.params.name. Anything, when you make these URLs, you can leave little placeholders here. And then the like value of this will be attached to the request object as rec.params. Whatever this is here. this correlates to that. So let's go ahead and make a profile view in our templating language. So we'll call this profile.handlebars. Cool. Say hello to, we call it the placeholder name. So again, trying to drive home the association, the link between this name and the name of the URL is made right here. This is what glues those two things together. And to demonstrate that, we're just gonna restart our code again. So we decided /profile/name will result in a web page that says say hello to name. Let's test it. /profile/Chuck. Say hello to Chuck. So that's dynamic routing. So if you had something like Twitter, you know, Twitter profiles are always just twitter.com/the name. So that's an example of that. So the last thing we kind of want to cover that I want to cover for like your absolute fundamental basics is how to take users' input and do something with it. So the way we're going to do that is with more requests. I mentioned before that there are multiple types of requests. When you hit enter in your browser's URL bar, when you hit refresh the page, that's a GET request. But there are other types of requests as well, and a lot of them contain a body as well, which is like a payload of some data. So like a GET request, there's no payload or data associated with it. There's just the request and there's some metadata. Let's just show it. Let's go ahead and make a simple message board in our homepage. So we're gonna do a little bit of HTML, just to make things nice. Messages. We're going to, the tag for a list is UL, and then each list item is LI. UL is unordered list, LI is list item. Okay, so we've got some messages, obviously hard-coded for now. And then on our home page, we're going to go ahead and inline this function. So I'm just going to delete it. And I'm just going to all right, so we're looking for something that looks like this. This is the website we're going to end up, but of course the goal here is to use the user's messages, not hard coding them into the web page. So how do we do that? Well, the first step is we need to collect the user's input somehow, and we're going to do that with a form. So let's run our first HTML form. HTML forms are accomplished with a form tag, and then they have a couple different attributes. Action equals something, and then method equals something. So we've already talked about methods, so I'll type that in first. You noticed we had GET request before. That's the method is the type of request. But this time we're going to send a POST request. A POST request is just a type of request that has some data. The sort of semantic meaning is to like submit information, which is what we're doing. There's other types of requests like patch and delete that are kind of less common, but don't worry about those for now. POST is really the meat and potatoes of making requests. And then action is when the form submits the request, it's going to be the path that the request is made to. So we'll make the action /message, and we'll hook that up in a minute. Input is accomplished with the input tag, and input is self-closing. So it actually, instead of having like a closing and an opening, you just put a slash before the end. So input type equals text. Placeholder, we can specify a value equals what do you want to say. And then we'll add a button, send, and then the button gets type equals submit. Submit button will submit the form. When the form gets submitted, it'll take our data and post it to /message. The other thing we need to do is we need to identify this by a name. So name equals message. text. So what I'm doing here, let me talk through that one more time. We have a form. Actually, let's look at the form. We have a form. It has a text box and a send button. The way the form works is we have the form itself is invisible. It's just a container. We've got our input, type equals text, ergo a text box with the placeholder. What do you want to say? What do you want to say? And we've got a button, and it's a submit button. So when you hit the submit button, the form is going to submit the data via post request to /message. And when we go to look at the data, we're going to be given like of key value pairs. We're going to be given an object of like the name of a field and the value of the field, and the name is determined by this name. So once we get into JavaScript land, which we're about to, we'll get an object that looks like this. It'll be an object, message text, and then whatever the user typed in. So then the question is, I've just promised you that we're going to get this object in JavaScript. How do we get it? How do we get this data? From the request. Again, we're going to read the Node standard library, can do this just fine, but we're going to reach for a library to help us out, just for the sake of time. So for this one, we're going to use body parser. Here we go. So we're going to grab it. Cool. And then we're going to import it just like we do all our other libraries. Remember I mentioned there are different ways to define variables. Var is one of them. We know we're not reassigning these, so I'm using const. Body parser. And then let's see what their documentation has to say about using it. Weird. You have to scroll really far. Anyway, so the way we register body parser is just by copying the code snippet from their example. So actually, I need to give that more explanation than that. The long and short of it is I have been explaining this to you as Express gets a request and then calls one of your functions. And that's true, but you can actually have it call more than one of your functions. In fact, you can call a lot of functions for different requests based on some criteria. And what happens is it'll call one function, and then it'll be up to that one function to pass control onto the next function, and then so on and so forth. And we call those functions middlewares. So Express has a stack of middleware functions that it will execute in some order. But we've only ever registered any of these. But this is actually a middleware function. So app.use simply says, call this for every request that you get. In fact, why don't we demonstrate this with our own middleware function? So in this middleware function, we're actually just going to console.log requested request made to, and then rec.path. I think it's rec.path, and then call next. So we have app.use allows us to register arbitrary functions to just run. So the body parser URL encoded function is one of those functions, and what it will do is, I need to close these files. When you submit a form, it encodes the data as a string in a format called URL encoded. And so the body parser library is going to parse that for us. And this is simply how you get to the middleware function. So a middleware function looks a heck of a lot like a normal route callback, except it has a third parameter, next. And when you're done with your middleware, you just call it. You say, all right, next. So let's demonstrate that. We're going to refresh the page. Nothing on the page has changed, but we can now see that 2 requests were made. Here's a fun fact. Your browser always just tries to load a file called favicon.ico. That's just like historically, whenever there's an icon in the tab bar, it's just a file called favicon. It has to be called that. Who knows? It's always going to do that every time I refresh the page. Oh, maybe not. Huh. Weird. It's only the first time you open a tab. Oh. Who knows? Anyway, we want to hook up this form to take some data. So we now have hooked up body parser. So now we should have the data available. Let's go ahead and check if we do. Rec.body. So body parser attaches the body of the request, which is, in our case, the data of the form, and puts it on rec.body. So we're expecting to get back some stuff. Except I am a fool. I'm sorry. We said in this form that we wanted to send the request to /message. So we've got to hook that up first. App.post, because we're making a post request, /message. Here we go. Now we can console.log rec.body. And we can, let's go ahead, because I don't feel like making a separate like confirmation page or anything of that nature for when the message goes through, we're just going to redirect them back to the home page. And slash is, of course, the home page. All right, let's start our code over again. Looks the same, but now I can enter a message, hit send, and I can now see that the request was made to / when I first loaded the page. Then I submitted the page, and the request was made to /message. And then in my /message handler, I logged this request.body, which was right here. And this was the object, message text, : what I typed in. And again, the name message text comes from this name here in the handlebars file. And then when we told it to redirect, then the browser then made another request to /. So I hope I'm doing an okay job of trying to sort of drive home the like request-focused way of thinking about a web application. But we have everything we need to make a message board now. And don't worry, in the 10 remaining minutes, you will be able to leave each other messages on my computer. Isn't it wonderful? So let's go ahead, normally you would use a database, and we can go over that if we have extra time. But for now, we're just going to use an array in memory. And so when we receive a message, that's what this means. When the client posts to /message, instead of just logging it, let's go ahead and messages.push rec.body.message text. Okay, message text. And then what we can do is let's go ahead and make our home handlebars. Instead of doing this, let's iterate over some messages. So for that, each, it might be double, I'm sorry, here we go. Each messages. If I haven't screwed up that syntax, what this is going to do is this is a part of the handlebars templating system where if you have a list of things, you can define how you want a single item in that list to work, and then it'll copy it for every item in that list. Use the each helper for that. So for each message, just make a list item and then fill it in with the thing that we're iterating over. So then we just have to pass in messages. So now, if I haven't messed up at all, this is empty, but as I type into it, we get messages. My friends, we have a working web application. This is exciting. So I am going to open the message board up to you. All righty. So if you want to go to this URL and leave me some messages, please keep it work safe. Sleepy, yeah, I'm feeling that too. It's like 2:30 in the morning. Chuck is webmaster. Oh, thank you. Don't know if I'd call myself a master yet. Oh, thank you, Paul. Thanks for the session. You're welcome. One thing I will point out is that if you want these messages to appear, you have to reload the page, right? Because that's like a fundamental part of how this is all working is we take a request and we send a response. But in order to take a request, there has to be a request. And the way that a request happens is the user refreshes this page. There is fundamentally no, because you're the one in chat, there's fundamentally no way for us, in the way we've done this right now, to keep it up to date. That's not true. We could totally implement that. It doesn't do it for us. It's something we have to implement ourselves. In order to make this, like do something like a messaging platform to like update the contents of the page periodically or on demand or something without having to refresh the page, then you need to run code in the user's browser that will make the request for them and then patch in the results. Yeah. So I've kind of rushed through all this, but hopefully I've given like sort of a high-level overview of the sort of path and technique to walk down. Whoever is confused, if you have any specific questions, feel free to drop them in chat. Otherwise, it's kind of a matter of like reading documentation and looking at sample code and just kind of feeling it out. I'm going to upload what I have right now to GitHub. Right now, actually, so that you have something that you can do, something that can be helpful. Let's see. Let's make a new repo. Sunhacks 2020. Crash course. What did I call this? Web development up and running. Web Dev 1. So I'm giving a talk later that's integrating React with the backend. So I want to make a distinction. Crash course, web development up and running. We'll make it public, create the repo. We'll go ahead and stop this, git init. When you start a Git repo, in Node, you get this Node modules folder that has all of your libraries and dependencies. You want to ignore it. .git ignore is the way you do that. Node modules. All right, that should update. There we go. All right. That was a poor name for a commit. All right, so how to extend it to two-way communication. Yeah, let me just get to the two-way communication thing real quick. The fundamental answer is if you want to be able to proactively send a message from the server to the client without the client having to initiate something, you can either fake it, which is have the client initiate something every 10 seconds or something like that, or every second, or even every 500 milliseconds, and just do that on a loop. And so that way you can sort of pretend that you're able to have real two-way communication. But if you really want real two-way communication, like have the server send a message to the client with no client-initiated interaction, you need to set up a WebSocket. I highly recommend socket.io is the library that I've used in many hackathons past, and it's very good, and it's very easy to use, and their getting started tutorial is excellent. Highly recommended. Cookie-related question. Okay. If we make an Axios request from a front end to an API, can the API send set cookie HTTP only? I tried once and it wasn't able to. You should be able to set HTTP only cookies. In fact, I would be really, it's quite complicated to set up HTTPS just for local development. Cookies should work just fine. So Himanshu's question is, like I was talking about in answer to the previous question, there are ways to initiate requests from the client manually instead of having to refresh the page or whatever. One of those ways is a HTTP client called Axios. So they're asking if they make an Axios request to their API, can the API send a cookie? So the answer is definitely yes. What I would check is if your front end and your back end are running on localhost but on different ports, cookies by default aren't shared between like localhost 3000 and localhost 8080 or something like that. They're considered different domains, and by default, cookies only apply to the domain that they were set on. So I would look into setting the domain explicitly to localhost or something like that. And the other thing that you might notice, Himanshu, is even if the cookie doesn't show up when you're trying to do like document.cookies or something, you might still see it being passed in requests to your API, subsequent requests, because browsers store cookies automatically and send them automatically. So as your front end is sending requests to your API, your front end may not even be able to see the cookie, but your API might. So I would look at that. If they're on a different domain, you just need to set the cookie options. You should look into cross-origin resource sharing cores. It might get hairy. Anyway, back to what I was saying. A cookie is a piece of data. It's just text, really. A cookie is text that is associated with a certain website. So you, the web server, if I am a user on your website, you might want to keep track of me. And I feel like cookies have this pop culture connotation of like spying and tracking and stuff, but like tracking the user that is using your website is like a fundamental feature to almost every website. Like when you log into a website, when you type in your username and password to twitter.com, Twitter needs a way to, in between individual requests, because remember, each time you switch pages or open a tweet or like something, it's a request. Twitter needs a way to keep track of all these requests were being made by you specifically. So they set a cookie. So the way cookies work is the server says, set cookie. It's a header. Their HTTP requests and response have headers that are just metadata, and one of the headers can be set cookie. So when you set a cookie, it sends down a set cookie header, and then the browser automatically stores that cookie, and then whenever anyone at all makes a request to that website again, it just includes that cookie in the new request in the cookies header. In fact, all right, before I go on, does anyone else have any other questions? Because I am not feeling too terribly tired. So if anyone wants to stick around, I can go over cookies next. And then I can go over databases are the two sort of things that I like to try to go over. So let's go over setting a cookie. We'll take it easy. Cool. We'll make cookies fast. So what I'm going to do is this isn't really a useful example of a cookie, but I'm just going to set a cookie for every time that every time you send a message, I'm just going to set a cookie with the last message you sent. Let me refresh this page just to see if anyone had any other notes before. Oh, I took it down. Oh, right. I need to, sorry, I got distracted. I need to I need to push my code to GitHub. One sec. All right, so now for all those that are departing us, here's the GitHub link. I'll attach that to the session or whatever I have to do and send it to the organizers or whatever. And then I'll be making additional branches for main will just be what we covered in the first session. And then I'll be adding branches for more stuff. So let's make a branch. All right, we're now in a cookie branch. Let's go ahead and do some cookies. So you can say res.cookie. Name of the cookie, we'll call it most recent message. And the value is going to be rec.body.message text. So the idea here is we're just going to have a cookie that remembers the last thing you said. All right, let's go ahead and run that code. Listening on 3000. Here we go. So all the messages cleared because we weren't storing them in a database. But just to prove a point, let's send some messages. And then I'll open my developer tools. In Firefox, you can look at storage under, look at cookies, excuse me, under storage tab. In Chrome, they're under the application tab. Show that. In Chrome, they're the application tab. You've got cookies. Anyway, you can see there's actually a handful of cookies here. I'll just focus on their name. Oh, apparently I can't. I'll just focus on their name. We have a handful of cookies already because I do localhost 3000 happens to be the port I use for doing work stuff at work. But anyway, point is we have a most recent message cookie, and that was our quarter because we set the cookie. If I say hello, then our most recent messages cookie is now hello. Fun stuff. Yeah, that's cookies for you. And then the other thing to note is I can do some logging on the server side if we want to really prove it to ourselves. But we'll come back to that. But I just want to show you that the request, the network tab, or in the DevTools will show you information about a request. And in this case, this was the / request, the request that like actually created the page. And we can see in the request headers, we have this giant cookie string, which is all the cookies for localhost. But you can see most recent message equals hello is in there. So that data made it to the server. That was sent as part of the initial request. So let's talk about databases now that we have cookies, although our cookies are useless because we're not reading them. But databases are straightforward in theory. The goal is messages can't just be an array. We need to store it. So generally, the way you interact with the database is that on this receiving message, we're going to write to it. And then every time you get a request to /, we're going to read from it. Makes sense. For hackathon projects and small personal stuff, I really like to use, I really like SQLite because most of the time, a database is like a software that you run somewhere on some computer, some infrastructure, and then you've got your application that you run on some infrastructure. They have to talk to each other over a network, or in your case, probably just two things running on the same computer. But SQLite is different. It is simply a self-contained thing in a file. So your database isn't like separate software. It's just it just reads to and writes from a file in your project directory. It's amazing. Highly recommended. It's so much more convenient than setting up MongoDB. People at hackathons always like to use MongoDB. It's a pain in the butt. Okay. Make sure this is the. Yep, this is the. This is the one I like. So let's go ahead and install the library. We'll make this fast. And the other thing I want to show you guys is that package JSON has been growing as we add dependencies. Just pointing that out. Let's hook it up. They're using import statements. That is okay. We also need to install SQLite 3, I think. Yeah, because that's the database driver. This package used to just be like a one-line install. I don't know why they made it so complicated, to be completely honest, but that's okay. Cool. All right, so let's go ahead and import this. Oh, sorry, we don't have import statements. Oh my God, I can't believe in JavaScript, there are import statements, but there's like certain conditions you have to meet to use them. Ignore that I typed that. I'll go over them when we're done with this. We'll go over some developer tooling when I'm done with databases. All right, what does their documentation say? SQLite.open. All righty. Oh, we're gonna have to go over promises. Wow, we're about to learn a lot. Just allow me to tell you. Let's put this over here. File name, we'll just call this data.db, SQLite3.database, then db, log, database open. All right, promises. A promise is a special type of object in JavaScript that represents like some data that will exist someday that we have to wait for. This is like a sort of fundamental idea with Node and JavaScript programming, is that it's all event-based, as we've been seeing. It's all like responding to requests or responding to events. But part of that is when you're like doing something that takes time, like reading to a database or making a request to another website or something like that, you want to relinquish execution. You want to say, okay, that's fine. Call me when you get back. So in other words, you pause your own stuff, and then you ask someone else to come get you to resume you when you're done. So a promise, is it getting weird? All right, let's. The long and short of it is a promise. We'll make this a little more clear. Const db promise equals that. There we go. All right, so a promise is just a special type of object that represents data that might be there eventually. So what this does is SQLite.open simply returns a promise, because most of the time when you're doing something that involves accessing data on a disk, you know that like disk I/O takes time, so you want to pause what you're doing and then you can resume when that time is done being taken, when it's done reading the file or when it's done making the request or whatever. So SQLite.open returns a promise that represents the database, and the promise will be resolved, is what we call it when a promise finally gets its data in there. The promise will be resolved when the database successfully like opens or creates the file. That's truly it in this case. So the way you handle promises is either you attach .then to them and then you attach a callback. So this code says, all right, when this promise resolves, when the database promise gets like filled with the database, then call this function and pass it in to the function. So when you .then on a promise, you get the value that the promise was resolved to. So promise is like a box, and then when it eventually has something in the box, then it'll call this function with the contents of the box. Just go with it. The other way to deal with a promise is with an asynchronous function. So if you have a function, let's actually just go for it. async. You know what? Let's just use this for real. Const setup database. It's an asynchronous function, and what we're going to do is we're going to say const db await db promise. So the other thing you can do with a promise is if you want, you can either attach a .then callback like we had shown before, or if you're inside of an async function, you can await the promise. So that allows you to write code basically as if it weren't a promise at all. You can just kind of use it how you want to. Just throw an await in front of it, and then you'll be able to get the value out of the box. So again, a promise is an empty box. Eventually, it gets filled with some content. There's no way to procedurally look into the box to check if there's content. There's only ways to register that you would like to be informed when the content gets there. And the ways to do that are either adding a .then or awaiting it. Anyway, that was really long-winded. This is how we get to our database, db.run. We need to set up a column for messages. Oh gosh, how much SQL do I remember? We use MongoDB at work. I apologize. Create column if not exists. Messages, ID, integer, primary key, message, text, string. Ooh, do I remember my SQL? I think that creates our. I think that'll create the columns that we need in order to store our messages, and then all the database access and operations are also asynchronous because they take time to do. So they also return promises. So we also have to await them. Okay, let's see if I'm right. I'm a little rusty at this whole SQL thing. Okay, off to a good start. You'll note it created a file, data.db, which is good because that's going to be our database file. Let's see if I can poke at it with my SQL client here. Is the screen sharing still messed up? Because I'm just realizing it looks messed up in my browser as well. And never mind, this is for traditional SQL stuff. That's okay, we can just interact with it directly. So we have this setup function. Actually, we need to call it to actually run. Okay, maybe if I turn off my video stream. Oh. All right, so it looks as though I made an oopsie with my SQL. Your column. Create table messages. Create table if not exists. Hey, I did it. Excellent. And while I'm here, I'm just gonna, I don't know why I don't have it on this computer, but the way I like poke at SQLite databases is with SQLite Studio. Again, I'm just gonna download it out of convenience. I'm gonna keep going while it's waiting. So we create table if not exist messages. We'll get to what to do when you need to update the shape of your data later. Let's just do as fast as we can, get the messages into a database, because that's what we're here for. That's what we're waiting. Okay, so when we receive a message, we want to insert that message into the database. Make this an async function. Go away. Make this an async function. Const db equals await db promise. All right, await db.run. Insert into messages. Oh man, I'm blanking on my SQL right now. Is it literally just values? No, it's messages, message, text. Here it is. What did we call it? Message text. Yeah, so it's going to be message text. I'm sorry, I'm jumping around a lot. Insert into messages, message text, values, question mark. And then the way that this library works is you leave question marks in your SQL statement, and then you pass them in sequentially as arguments. Okay. We'll get rid of that cookie because we're not using it for anything. Anyway, wait, db.run, insert into messages, message, you specify the column, you say the word values, and you specify the values. So that should insert the messages into our database. We're also going to retrieve them. So again, let's make this an async function. Again, notice you always have to, the only way to get the value out of a promise is to .then or to await it. So you have to await it. Even though we're pretty much guaranteed to already have the database open by the time someone hits one of these routes. Okay. Oh, SQL actually does need semicolons. Cool. Sick. That actually should do it. Let's give it a go. See if we got this. Object. That's actually a success. So what happened is, let me go ahead and log this for you. And we're going to delete this. We're going to delete this middleware because it's annoying. So now, if we refresh the page, even though I stopped and started the code, the messages are still there. They still say object. I'll get to that in a second. But you'll see when I console log the messages, each message is an object with an ID and message text. ID, message text, because these are the columns we made in our table when we set up the database. So the only thing left to do is, now that before messages was an array of strings, but now it's an array of these objects, so we just got to update our template. So in our home.handlebars, we'll say this .message text. Okay, so now our messages actually store to a database. That's it. There's a completely persistent database. Look, I can stop my code. When I start it again, the messages are still there. And also, because it's a database file, we're going to go ahead and ignore it. Any .db file, really. There we go. Yeah, so there's a message board with databases. Easy peasy. One thing you'll note is that each message has an ID, which is one of the columns we defined when we initially set up our table. We said ID integer primary key, but we don't actually set it when we insert into it, because SQLite specifically will automatically increment a column if you have it marked integer primary key. And if you don't create an ID column, there's actually a hidden ID column that exists. Yeah, so this branch didn't end up being about cookies. So I'm gonna new branch, databases, add databases. Cool. So now on that GitHub link, there's a databases branch that includes the stuff you need for the databases. So last year I gave a rambling 5-hour talk that included like user authentication and login and that sort of thing. I don't know if I have the stamina for 5 hours, but does anyone have any questions or anything that any like web technologies or techniques that you would like me to go through? And just to say, what we've built here is a server rendered application, which is, like I said, request response. And the only time the page ever updates is when the browser itself refreshes or navigates. If you want something more interactive that like has things that happen when you click them, actually, yeah, if you want something like much more interactive, you're gonna reach for client-side code, which is JavaScript that runs in the user's browser instead of on your server. And you'll probably end up using a library such as React. So for something like that, you should visit Ali DiNapoli's React talk later this morning. And then after that, I'll be giving a talk on how to integrate a React front end with an actual Express API backend. So yeah, this was a scatterbrained crash course on web development. Can we use Firebase for user authentication or verifying email? Yeah, absolutely. So I think Firebase has APIs that you can call directly from your front end, and they also have APIs you can call from your back end. So that's totally cool, totally chill. I hear great things about Firebase. I tend to roll my own authentication because it's actually quite simple. And perhaps I can, oh man, how ambitious am I? Would people be down, if you wanted to see like an example of just like the simplest user authentication system that we could pull off in Express, that might take another hour. Would people be down for that? Well, let me just, screw it. We're going to build an authentication system. Feel free to drop out at any time. I see we still got 8 people here, so I'm just going to keep going for the sake of the 8 people that are quietly watching in chat. So let's do a little bit of housekeeping before we move on. The first bit of housekeeping that I want to do is, I mentioned before there's different ways of importing stuff in JavaScript. And I want to get the newer, the sort of more modern way of importing with import and export statements. That's called ES modules. And I'm going to install a package that lets us use ES modules. I think it's just called ESM. Yeah. Sick. That's literally it. All right. So this is what we're going to call a development dependency. So npm install save dev ESM. So then now in order to use import statements, our start command would be node-r ESM index.js. However, remembering to pass that in might get a little clunky. So instead, we're also going to define a script in our package.json. Something that package.json can do is you can define scripts. They include a sample one that just shames you for not writing tests. But if we write one called start, we could say node-r ESM index.js. Now, instead of typing that into our console every time, we can simply say npm start. Oh, is the stream being weird again? wonder why my microphone didn't work. That's also really surprising. I recorded a video just with all my inputs in QuickTime before I started, and it seemed fine. Is my stream back to normal? Okay, cool. Let's move on. So that's the first bit of housekeeping, and so that's going to allow me to refactor this a little bit when I do that. Or am I? Oh, it's just when I'm switching windows. But if I do this, it doesn't screw up. All right, well, I guess I'll do this. Anyway, adding ESM lets me refactor these. So I'll comment them out so I don't forget any of them. Import express from express. Oh, that's disappointing. I like that microphone. All right. Import exp HBS from express handlebars. Import body parser from body parser. So why the heck did I rewrite these imports in just the new syntax? Well, one, we're going to be actually breaking apart into a separate module in just a minute. But also because this allows me to import just part of an agent space. So I can actually do this, import open. So instead of saying SQLite.open, I can just import the open function because that's all I need. Just a fun little tip. You might see that in sample code or you might see that in like sample code or something around the web. Okay, so we've done a little bit of refactoring. The other thing I want to do is I'm getting kind of annoyed starting the code all the time, so I'm going to do something about that as well. There's a package called Nodemon or Nodemon or something. I don't know who knows how to pronounce this, but that, another development dependency. And so Nodemon is like Node. It runs your code, but it restarts it. Nodemon. It restarts it every time you change your code. So that's just convenient. It's just really nice. So again, we'll go into our package JSON, Nodemon. Cool. I think that's the housekeeping. Oh, the other housekeeping I wanted to do is this. This is not going to cut it. When it comes to using databases in the real world, you're inevitably going to define the shape of your database, and then it's going to change. And when you need to make a change from one to the other, you need to make sure that you can make that change without breaking any code or losing any data, screwing anything up. So there's this concept of migration, which is simply you end up writing code to move data from one shape to another. What I'm getting to is the SQLite package we're using has like a built-in migration system that we should use. So what I'm going to do instead is I'm going to say await db.migrate. So then that'll just instruct the database to run its migration. So how the heck do migrations work? Well, it depends on the library you're using. But the way that SQLite does it is here we go. Come on. Migration / Yep, okay. So the way it works is you make a migrations file, and you do like 001 initial schema.sql. And then the way these work is that the library will keep track for you of what the number was in front of the one that ran most recently. So if you just run the code with number 1 and then you like make a new one called to update whatever.sql, and then you call db.migrate again, it'll see that number 1 ran but number 2 didn't, and then it'll run number 2. So it keeps track of what migration you're on for you. So but we're not even going to be using that. Let's just, oh my gosh, my brain is fried. The takeaway from that is just like we're making a file called this, and then it will be run by our SQL package for us. Oh my gosh. Create table messages. So I'm just going to go ahead and lay out the database. Normally, I would sort of build up to this in steps, but I'm going to just lay out the database that we're going to need and then talk through the decisions that I made. Actually, we don't technically need that for consistency. Okay, am I forgetting anything? Yes, I'm forgetting the foreign key. All right, so my plan is the sort of core piece of information that we need is a message, and at its heart, a message is just message text. But and I decided it might be convenient to know when the message was sent. And every record in a database needs a unique primary key. So in this case, I'm just going to be consistent and just call it ID and make it an integer. What's going to happen here is I want to keep track of which user sent which message. So each message is going to have an author ID field, and that is going to reference the ID of one of the users. So key author ID references users ID. Is that how that works? Hold on. I have to Google the yes, got it. Cool. I remember my SQLite. Ditto over here, we're going to need foreign keys. So a user posts a message. But when we're talking about login systems, you basically have three major components you have to think about. You have to think about registering the users, which just means taking their email, their password, their name, and storing it. You have to think about logging them in, which is just taking the email and the password from like a login form and determining which user that is and if they typed their password correctly. And then the third component, the important part, is you need to then, once you've logged in and said, okay, this user sent me the username and password and I believe them, I have determined that it's them, you need to remember who they are for the rest of your requests. And the way you do that is with cookies and access tokens. So what we're going to do is we're going to have a whole table of these access tokens. And all they are is just like an unguessable string and the user that's associated with it. So what we're going to do is we're going to generate an unguessable string. We're going to, when the user logs in, we're going to set it as a cookie on their computer. So that way, every time we get a request from them, it'll include that cookie with that unguessable string. And we're going to store that unguessable string in the database. And alongside that, we're going to store what user it's associated with. So that every time we get a request, if we want to know which user made that request, we simply look up that string in this database and check the user ID field. So token is the name of that unguessable string. So in the migration world, you need to write the migration, and then usually you also write instructions for how to undo the migration in case something goes wrong. In this case, our migration is just creating the whole database. So the way to undo it is to just delete all the content. Drop table messages, drop table users, drop table access tokens. Okay, so now we've got all the database stuff we need. The next thing we need to do is, I'm debating what I want to do first. Let's do a registration page. I think that'll probably be the easiest. So let's go ahead and make a new view, call it register.handlebars. Oh, before we move on, we're going to clean up some of this old code. We don't need this shit anymore. Goodbye. All right, so this one, H1 register. Let's make a form. Action equals register. Method equals post. Input type equals, there's actually a special type for email. Name equals email. Placeholder equals email. Input. So we'll make another placeholder equals password. We should ask for people's names. Did I say we were going to store names? I said we were going to store names. Let's make a name field. Put name placeholder equals name. And then button type equals submit. Okay, so we have a register page. Let's wire that up. That should be pretty easy. Get register. All right, that should be pretty straightforward. npm run start. Uh-oh, I screwed up, my table messages already exist. Oh, yeah. All right, there we go. So let's go ahead and go to our page. We can go to /register. Name, email, password, register. It is not pretty, but it sure is 3 text boxes and a button. And that'll do for now. So let's go ahead and handle user registration. App.post. So now what's going to happen is like we said before, the action and method are like the request that gets sent when you submit the form. So what we're going to do here is app.get is the request that happens when the user just goes to the page. It's the GET request. Like I said, whenever you go to a URL in your browser, it's a GET request. But since we're sending a POST request, we app.post to /register to receive the data. So let's grab our database. The first thing we need to do is make sure the user doesn't already exist. Before we do that. So this is some shorthand for doing like const name equals rect out body dot name const email equals rect, etc. So you can imagine if you just had like an object, you want to get some variables out of it, you can imagine how this would get like annoying pretty quickly. Oh man, it's frozen again, isn't it? Anyway, you can imagine how this would get frustrating to deal with over a long period of time, or if you had to do a lot of them. So this is just kind of a more convenient shorthand for doing that. So first, we're going to make sure the user doesn't already exist. So select star from users where email equals question mark, and we'll pass an email as the second parameter there. And then if existing user, usually I do error handling stuff, but for now, let's just redirect them. Slash. We'll get to better error handling in a minute. No, we can't skip error handling. Okay, we'll take it easy. We'll do it the easy way. What we're going to do is actually we'll add this to the main file, which is our layout. What we're going to do is we're going to just add if error div style equals color maroon. Who knows? So what we're going to do here is we've added a field to the main layout, which is the layout all of our pages use right now because we haven't made any other ones. And so now if we just pass in an error field to any of our templates, it'll show up in red at the very top. And we can validate that really quickly by looking at our register page. Again, we pass in fields like this. So now we should have a register page that says test in maroon at the top. We can make this look more scary, but we're not going to. Anyway, so now we can render templates with error messages. So instead of redirecting home, if the user already exists, let's show an error message. Render register. We'll give them the register form again, but this time we'll give them with an error. User already exists. All right, if the user already exists, we need to do this, and then we want to return out the function so we don't keep doing things because we've encountered an error. Too bad, we're done. So something I want to make really clear about authentication systems is never store the user's password in plain text. Just don't do it. Just don't do it. You got to hash it. So we're going to grab a library to hash it for us. That's going to be bcrypt. I think it's just bcrypt. Yep. Yep. Oh, pasted it twice. All right, so what we're going to do is we're going to const password hash await. Oh, gotta import bcrypt. Bcrypt. Here we go. And then bcrypt dot hash and then 10. So bcrypt.hash will take in the password and produce something unintelligible. that is safe to store in our database. And then 10 is just like a configuration option you pass to decrypt. It's called the salt rounds. Don't know anything about cryptography. It's just what the documentation says. Anyway, so now we have the name, we have the email, we have the password. But of course, we're not storing the actual password, storing the password hash. Now we have enough to create the user. db.run. I'm going to make a string with, there's 3 ways to do strings in JavaScript: single quotes, double quotes, or backticks. Backticks are kind of cool because they let you do multi-lines, and they also have placeholders, but I'm going to do backticks so we have more room. Insert into users, name, email, password. Values, question mark, question mark, question mark. And then the arguments are going to be name, email, password, hash. Better not catch you putting passwords in the database. Oh man, that made that much harder to read. I'm sorry. That was unnecessary. Here we go. That's a little easier, right? So this is a function that takes 4 arguments. The first argument is the SQL statement string with a semicolon, and then the next 3 arguments are these question marks. Okay, so now we should have a user. Just to validate that it worked, const new user wait db.get. That's how you look up a single record. Select star from users where email equals blank. Check the email. All right, so we're going to store the user and then immediately retrieve them by email. We expect emails to be unique. We could enforce that at the database level, but we've done it here by just checking. We'll console log and then we'll redirect to the home page when they successfully register. Okay, so we just kind of wrote that blind. Let's hope that worked. I've lost track of which windows are which. This one. Okay. Oh, I screwed up. Here we go. Cool, we have a register page. Name, Chuck. Email, chuck@chuckbreeze.com. I've typed a password. I hit enter. It redirected us. That's a good sign. And you'll see we got our new user, ID1, email, that password, not what I typed. I don't know how close attention you were paying, but I only typed 6 characters. And this is many more than that. And a name. And it generated an ID for us. All right, so what the hell is this password string? It's called a hash. The idea behind a hash is that you can put data in and it'll spit data out. And you have no way of taking the output data and determining what the input data was. In theory, it's like impossible to figure out what the original password was by looking at this. But when the user tries to log in next time, I can run what they try to log in with as their password through the same hashing function. And then these will match. Actually, they won't literally match because of salting, another cryptography thing. But the point is, you just hash the password when you save it, and then you just hash it whenever you need to check it. And so you never need to know what the actual password was at all. Oh man, I'm getting tired. So this is login, or this is register. Go ahead and commit it. So once we have registration, we need login. And then once we have login, we need posting as a user. So let's do login. Let's make a new file. Can I get some positive confirmation in chat that people are still like paying attention and want me to continue? Because honestly, I'm getting a little bit tired and I'm down to keep going, but okay, I'll keep going. I can keep going. So we're going to make a new file. We'll call it auth.js. And the goal here is we're going to have some functions that get shared. The first function we're going to have is called grant access token. So when you register for the first time or when you log in, we need to grant you. Yeah, I might switch to pseudocode soon, but for now I'm going to try to power through. Anyway, let me know if I get completely incoherent. Like I mentioned before, when we were setting up our database, we have this concept of an access token, which is a one-to-one association between a user and the user's browser. So you have an access token for Firefox on your laptop. You have an access token for Safari on your iPhone. So we need to grant you an access token when you log in, but also, we should grant it to you when you register. We shouldn't register and then immediately make you type your password in the login form. That seems silly. Although I've definitely seen that done, I think it's dumb. So we're going to write a function to grant the access token. So auth.js is just going to be a file that holds some functions. Export const grant access token equals an async function. We'll take the user ID as a parameter. So what we got to do, generate unique token, create database, entry, return token, and then calling function will take care of setting cookies. Okay, sorry. So the only real interesting question here is how do we generate the unique token? And the way, of course, in all things JavaScript is to find a package to do it for you. In this case, we're using UUID. Just go ahead and grab it. And then the other thing is there are different types of UUIDs, but v4 is just totally random. So what it does is you call it and it gives you out a random string that is like extremely, extremely unlikely to be not unique. So it's extremely hard to guess, which is exactly what we want because, like I said, access token is an association between you and your browser. If someone can guess the access token, then they can pretend to be you. So we want something unguessable, and this shit is unguessable. We'll go ahead and grab the import statement. We'll import it here, and then we'll just call it. So const token equals v UID v4. Alrighty, there's that. Let's go ahead and take the database as a parameter too, might as well, because it'll already be in scope when we call this function. Wait, db.run, insert into tokens. Values, question mark, token, user ID. Okay, that'll do that. And we just return token. Easy. So the idea here is that we've done all this stuff. We've got the new user, and then let's go ahead and grant them a token. Const token. So something to note is because I made this an async function, in order to use the return value, I have to await it because async functions are promises. Also, something I should have showed you is when I typed out the name of the function, VS Code imported it for me. But you got to import the function like this. Okay, back on task. We wanted to pass in the user ID, and we need the database. Okay, so now we have everything we need to be granted an access token. I'm going to delete the database again and run start. All right, so I should go to the register page. I'm going to clear out my cookies just for demonstration's purpose. All right, I'm going to log in, and it should grant me an access token cookie. Did it? No, it didn't, because I'm an idiot, and I have to actually set the cookie. I knew I was forgetting something. Okay, now it will set the cookie. But before we do, let's take a look at our database, shall we? Just to validate that the stuff, we've been doing a lot of stuff sort of blindly, and I'd like to be able to verify that what we're doing is working. So here we go. We'll just take a look-see at our database. If I turn off my video, does my screen get bigger? I have to do the dumb Mac thing. Literally so many button presses just to open an application I downloaded on the internet. It's truly incredible. That's okay, I can't complain too much. All right, this is probably really hard to see on the screen. Actually, though, I wonder if I can't do something about this. Does that zoom for you guys? No, it doesn't look like it does. If this next thing doesn't work, I'll zoom style, picture in picture. Oh, really? The screen capture doesn't capture it captures the box, but not the actual Zoom content. That's a shame. Okay, but the point I'm trying to make is we have 4 tables: access tokens, messages, migrations, and users. Migrations was generated for us. I can get these. So in the access tokens table, I've got 1 access token with this token, user ID of 1 and ID of 1. In the users table, I've got a user with this password and the name. Okay, cool. So the data exists, is my point. So we got a user, and then they got an associated access token granted, is what I wanted to show. Let's delete the database file and then run it again, just to show that our cookies are working. All right, there's the access token cookie, and there's the value. And if we were to go look at the database, we would see it. So our next task, well, we can do login or we can deserialize. Let's do login first because it's basically the same as register. It's just you're looking it up instead of saving a new one. So let's go ahead and make a login page. Well, let's make the form first. Views, new file, bars. Here we go. Login. So for this one, all we need is an email and a password. Put type equals email, name equals email, placeholder equals email. Put password All right, there's a login form, pretty basic stuff. At least if you know HTML, and if you don't, then it at least looks like the register form. All right, let's make a page to render it. We're going to app.get, just like we have been for all our other pages, /login. And another async function. Well, actually, this one doesn't need to be async. Rec res, just like all our others. Hope sensing pattern, render, login. That's easy. Easy peasy. Awesome. Email and a password field. We just got to hook up the listener for that now. This one will need to be async. Again, gotta wait the DB promise. Again, we're gonna try to look up the email, but this time we don't need to error if we find them because we're hoping to find them, so it's a little different. Existing user equals await. Get. Well, select star from users where email equals question mark. And let's go ahead and destructure again. Const email password equals await, or nope, rec.body. I'm losing it. Here we go. Oh, hold on. There we go. Do email. All right, so now if there is not an existing user, then we want to res.render login error email or password incorrect. Just, generic error message and then return. Cool. If we do find the email, then we need to check the password. Word matches equals await. So the way we check the password is we ran it through a bcrypt hash function when we saved it to the database. And we have a unhashed password that they've just sent us in the form. The way we compare them is we just let bcrypt do the comparing. Bcrypt.compare. The incoming data is going to be password. The encrypted data to be compared against is going to be existing user.password. The password we stored in the database. If password doesn't match, so not password matches, res.render, I'll just copy this. The reason these error messages are the same is because it's considered better practice to return the same error message if the email or the password is incorrect, even though you personally, the code, knows which one it is. You don't want to accidentally confirm or deny the fact that a given user has an account on your system, if that makes sense. It's like a kind of a privacy thing. It's like I could tell if someone had an account on this website by just like typing their email and a garbage password. So that's why you want to return the same error message for both cases. All right, but if the password does match, then we make it down here. We're going to say const token equals await grant access token existing user.id and database res.cookie access token, gotta save the token to a cookie, redirect slash. Okie dokie. So now our register works and our login should work too. So if I clear these cookies, I should be able to log in. First, we'll test one of our error cases. Cool. We'll test our other error case where I mistyped the password. Cool. But if I finally do it, hey, look at that. We got our access token cookie. So login and register both work. And we can actually look at this again and see that in SQLite Studio, our users still has one, but we should have 2 access tokens because when I cleared out my cookies, we still had the first one from when we set up register, but I didn't delete it from the database, I only deleted the cookie. So when you eventually implement logout, which I won't be going over here, make sure you clear the user's access token cookie and delete it from the database as well. So we have login, we have register. The question now is, both of these have just been avenues to get an access token into the user's browser. What the heck do we do with the access token now that it's there? Well, we read it because it's a cookie. So you can see in the request, that is the / request, it sends it as a header. So we need to grab that cookie. We need to go look up the access token that the users that the token is associated with, and then we need to go look up the user that is associated with that token for every single request. So this is where that middleware stuff I was talking about 2 hours ago comes in, really handy. Rephrase, we're going to write a middleware that looks for the access token cookie in the header. If it finds it, it will look up the associated user and pass it on to subsequent functions in our call stack. So let's do it. Let's make a export const lookup user by token. Const access token. I realize we need the actual token. Await db dot get select star from access tokens where token equals question mark token. If there's no access token, then we know they're not logged in. They can't be. So let's move on. Const get select star from where ID equals blank. And that value is going to be access token dot user ID, I think. Access tokens user ID. Yep, that's the one. Oh, my screen's fucked up again. There we go. Okay. If we don't have a user, well, let's just return user. So again, this one's pretty simple. It's just it's just 2 database queries. And then what we're going to do is in our main thing, we're going to add a new middleware. Keep that in more. App.use. So in every route, we're going to run a function. Make it async. Const. Oh, the space before async in the parens is optional. db equals await db promise. User equals await lookup user by token. rec.cookies.access token. User next. And then rec.user equals user next. All right, so let me talk through what's happening right here. We're expecting an access token cookie in the headers, in the cookie header. So we're gonna install a package that automatically adds all the cookies to rec.cookies. So we just grab it, rec.cookies.accessToken. We just wrote our lookup user by token function, which simply queries for the token database record and then queries for the user. If we don't return a user, if we don't find a user, then that means either they didn't pass a token in at all, or they passed in a token, but it didn't exist. So we just move on. Again, inside of a middleware, to move on, you call next. You must call next. The request will never resolve if you don't call next. But if we do find a user, then we're going to attach that directly to the request object and then move on. So now any subsequent function call, any subsequent middleware functions will have a rec.user that we can just look at to tell if the user is logged in. I think we're good. Fingers crossed. Let's see. Let's no, I know what we're forgetting. Cookie parsing isn't done automatically. We have to find the package to do that. I think it's called Cookie Parser. Did Express? I swear, I thought I heard that they were planning on implementing that. Sorry, I haven't had to do the cookie dash parser. I knew that didn't look right. There it is. That's what I used to sing. Okay, let's install cookie parser. Man, what would we do with that npm? Seriously. Import. And then, of course, we expect to be able to use cookies in this app.use, so we just got to run the cookie parser before that. All right, so now we should be set. Fingers crossed I didn't forget anything, but let's give it a shot. No errors. That's good. Refresh the page. We did it. All right. Ladies and gentlemen, we have a fully functional authentication system right now. Recap. We have set it up such that in any of our endpoints, any of our routes at all, we can simply look at rec.user to know if the user is logged in or not. Yeah, so this is I mean, we've been here since 1:30 in the morning. I don't know. I feel like we're actually making good progress. So I'm going to commit this and push it. But we still have a little bit of work to do. So let's push. Yep. What we need to do now is the whole point of adding users was to associate the user with the message that they sent, right? So let's do that now. A couple things. First of all, let's not even show them the message form if they're not logged in. Let's make you log in to send a message. That's on the home page. This form, if user. And then, so if there's a user, then we'll show the form. Otherwise, we're going to show some buttons. If you haven't inferred this, the A tag is a link. Okie dokie. So let's go ahead and give this a shot. I didn't need to do that. That's okay. So I'm not logged in. I actually, all right, so here's what happened is I instructed the template to say, if user, show the form, otherwise show login and register links. However, I'm currently logged in, but I didn't pass that information from the route into the template. So we got to do that. So in our homepage, messages, user, ref.user. So now when I refresh the page, I should get perfect field. So we don't need to modify the message field at all, but we need to update the function that handles the message data to now save the currently logged in user and the current date alongside the message text. So now we'll go back down here to, oh, I'm losing track. Here we go. Insert into messages, message text, author ID, date, values, question mark, question mark, question mark. And let's do this message, rec.user.id, and date. New date dot to I'm gonna do something really quickly. How do I get Unix time out of JavaScript dates? Is it just UTC date.now? There it is. I knew it was something. Dates in JavaScript are kind of a mess. I'm sorry. I shouldn't have spent so much time on that. I should know my stuff, know my craft better. All right, so we should be good to go. Let me double check. So in the messages table, we expect message text, author ID, date, and ID is generated for us. Message text, author ID, date. Message user ID, date. Oh, here's a note. So if rec.user doesn't exist, then when it tries to get to ID, it's going to blow up and throw an error. But you shouldn't be able to. You shouldn't be able to send a message if you're not logged in. So let's just do some error checking. If not rec.user return res.status. There's an error code for this. Response status codes. All right. There's, 404, error 404. Well, there's more than just 404. All right, so 401 means you're not logged in. So status 401. Let's send not. We don't expect it to be possible to do this if you're not logged to get to this point if you're not logged in, but it's always better to be safe than sorry. Ditto with the. Oh, actually, that should do it. So let's take a look at our code. Let's send a message, hello. We get the hello, and then in our database, we get the message text, the author ID, the date, and the ID of the message itself, which is good because then, I mean, we're really there, aren't we? You know, we know now who sent each message. And if I reopen my thing to you guys, if you go here, you should be able to log in or register and send a message, and then I'll be able to tell what's going on in here. If someone wants to send me a message, that'd be chill. Or not, I don't really care. So what do we need to do? It would be helpful to display the name of the author next to the message. That seems reasonable. What's up? Hey, nice. And look at that, author ID 3. So let's take a look at our users. We've got 4 users. Look at that. And guess what? It didn't store anyone's passwords in plain text. Good stuff. You are welcome, my friend. I can see who sent the message. Let's see. Who said thank you? That was user author ID 2. You're welcome, Pratik. But of course, we're not going to provide the users a table of user IDs to names to go look up who wrote the message. We're going to display the name next to the message. So let's get on top of that. So when we're looking up the message, when we select the messages, we're going to have to make ourselves a much more complex SQL statement. So let's start here. Select we're going to have to do this by hand. That's kind of a shame. That's okay. Select ID, message, text. Yeah. This is recording right now, so I'll have it at YouTube. But also, I'll have the code itself is on GitHub. I'll repost that link. I'll just post it now. Why not? Sorry, I have it somewhere. Let me see. So we're going to do that under the user authentication branch. All right, so here's a link to where we're at right now, and I'll push to it as we go, just so you have the code available. Okay, so we're going to grab these message text. We need the date, and then instead of grabbing the author ID, we're going to grab messages.id. We're going to do a join. And we need to do users.name as author name from messages left join users where messages. Again, my SQL is rusty, but I think this should do the trick for us. So now if I go back, refresh the page, yay. Aha! So that, my friends, is a SQL join. So now the messages array is ID, text, date, and instead of an author ID, we've managed to create an author name field. And I don't have the expertise to truly explain SQL, but if you just Google SQL joins, you will find what you need to write something at least as simple as this. So now we just got to update our template. So li, let's say this.author name. We'll do the author name, and then we'll do like a colon. So it's like name colon message. We'll save it. Look at that. We did it. I think this feels like a good place for me to log off for today. This seems like a decent stopping point. Let me commit what I have. Show author of messages. Push. All right, all of the code is on GitHub. I will talk to organizers to figure out how to get this video link up and distributed. Yeah, I hope you've all enjoyed. Yeah. Have a nice day. Yeah, you're welcome. This is I like to give this talk because it's kind of a culmination of all the things that I had known when I went into my first hackathon, because it's really like fundamentally it's kind of everything you need. So yeah, and then if you want something rich and interactive on the client, you can attend Ali's React talk, and then I'll be giving a talk on integrating something like this backend with React instead of with handlebars templates. Any chance I've got any moderators in here? Polly's still here, Cecilia, something like that. How do I end the session? So I'm just gonna sit here and look through my Discord while. Yeah, really appreciate that. Oh gosh, is anyone even online still? Looks like Cecilia's still. Ah, dang. She has DMs turned off. That's okay. I think if I just leave, it'll work. It'll end, maybe, perhaps. Well, let's see. If you leave, you'll have to request again. How do I end it? I don't know if I'm allowed to end it. Paul, I bet Paul's asleep. Hold on. I'm just gonna. I guess I'm just gonna hang out, or I think maybe if I just leave, it'll be fine. Well, goodbye, everybody.